Hey guys, how's it going? Got a couple of joining us. Thanks for joining us today. We'll kick off in a couple of minutes' time. Um, Once again, for people that are just joining us, a warm welcome on behalf of Snowflake. I'm Vishnu here, and today we're going to be looking at Zero to Snowflake, roughly everything to do with Snowflake and its power to get you started and for you to maximize the potential of Snowflake. Once again, welcome everybody. I'm going to quickly share my screen and get started. But while I'm doing that, feel free to familiarize yourself with all the options that you have in front of you on the screen here. Feel free to go through the resources tab. That's got everything for you to follow through the hands-on lab today, follow through the content today. You must have received pre-work as well in your emails to set up a Snowflake account, but we also have a guide to the quick start that we'll be following today. If you haven't done that already, no problems. I'll walk you through setting up of a Snowflake account in the session as well. Once again, welcome. I'm going to share my screen quickly and take you through the session. Awesome. Thanks, guys. Like I said at the start, it's Zero Snowflake, so it's meant to give you a brief overview of the platform, what the platform solves in terms of capabilities, the various workloads that we power. And also, we will, in the latter half of the session, jump into a couple of hands-on labs to get your hands dirty and show you what it feels like to be using Snowflake for your data warehousing requirements, but also for your data engineering requirements as well. All right, let's get started. I'm Vishnu Rajmohan. I'm a solution engineer at Snowflake. I've been at Snowflake for close to about a couple of years now. And obviously, from the time that I've joined, the platform's massively expanded in its scope, had a lot of features come out, particularly related to ML, AI, and also in the data engineering space. So feel free to check out other resources, other documentations as well after this hands-on lab. There's a bunch of other resources that are attached in the resources tag, in the resources section on the Zoom window. There's other hands-on labs that are coming up as well, so feel free to check them out, and hopefully you can access some of the other hands-on labs that will deep dive into some of our newer recent capabilities as well. This is a live event, so we are advancing in the space of AI, but we still don't have robots at Snowflake presenting to you guys. And what that means is you have a live speaker, but also you have a person behind the scenes. We've got Stephen Weingartner, who is going to help us answer questions. So let's try to keep this as interactive as possible. So if you have any questions, pop them in the chat window, and we'll try to get them answered as quickly as possible. All right, without any further ado, let's get started. A bit of housekeeping. Like I said, the resources tab in the bottom right-hand side corner. Feel free to check it out. This is the agenda for today's session. We'll go through a brief technical overview of Snowflake, of the platform in itself. I'll walk you through the architecture of Snowflake as well, and show you how the platform's architected for performance and scale. We'll do that in the first half of the session, and then we'll walk through the journey in terms of onboarding Snowflake and using Snowflake in the shoes of a customer. This is going to be a fictitious customer again. I'm going to call it Tasty Bites, and we'll see how a customer typically approaches Snowflake and what a customer is expected to do in the platform as they onboard into the platform. We'll conclude with some live demos as well. Like I said at the start, we'll see how many demos we can cover. I've got a couple of hands-on labs that I'm intending to cover today, but if you have time, I'm happy to show you a few more as well. All right. So for people that haven't signed up to the Snowflake free trial, feel free to use this QR code, or there's a link here as well, or this should be available in your resources tab too. So check it out. Click on the sign up tab, the link on the screen, and it'll prompt you to enter a few pieces of information. So once you enter in your personal information in there, including your email address, you will be taken into another screen where you select an addition of Snowflake along with a cloud service provider and a region to deploy Snowflake within. Now, that's all that you're supposed to do to get up and running using a Snowflake platform. All right, so for this one, the recommendation is to use the Enterprise Edition, and that's mentioned in the resources section as well. Feel free to select a cloud service provider of choice and a region of choice as well. For this particular demo, I'm going to be using AWS as my underlying cloud service provider, and I'm going to be using Asia Pacific Sydney. And I'm based out of Sydney, and that's mainly why I'm going to be doing this. Now, once you enter in all of this information, make sure you do this in the next couple of minutes so we stay on track as well. I'm also aware of the fact that a few of us may have already done this, so excuse us. Please be patient as we run through this for others who may have not completed the pre-work. We'll get through this in the next couple of minutes and quickly get started on the session, but also the hands-on labs. All right, cool. And once you've done that, you should have received an email from Snowflake to activate your account. Click on Activate, and that should take you onto the next screen where you enter in your username and password. Please make sure that you note this down somewhere else as well, or make sure that you remember this, because this information will not be presented again once you sign out of the platform. Sorry, just quickly checking in the chat window to make sure everything is well. Yep, perfect. We've got more participants joining us as well as we kind of ramp up into the session. Like I said earlier, for others that are joining us just now, feel free to put your questions as we go through the session in the Q&A window. We've got a solution engineer behind the scenes, Stephen, that will help us answer your questions. All right, so once you've entered your username and password, that should basically sign you up into the Snowflake ecosystem. All right, so you can set that screen aside for now, and I'll walk you through what we would need to do once we get diving into the hands-on lab. But before we do that, I want to quickly introduce you about Snowflake. Firstly, to walk you through what Snowflake represents, what capabilities we provide, and walk you through some of the architectural considerations as well. And then we get started with the hands-on lab. All right. A little bit of housekeeping. I'm sure this would be a question that's top of mind for some participants today. The webinar will be shared with all of you in the next couple of days. Keep in mind, the slides will not be shared themselves. The webinar, the recording of the webinar will be shared. If you have any questions, like I said, use the Q&A window. All right, now a little bit about Snowflake. So Snowflake, as an engine, is pretty much cloud agnostic, it's region agnostic as well, as you've seen during the sign-up process, but also it is architecturally agnostic. And what I mean by that is that Snowflake can support any different architectural pattern. So be it data warehousing, data lakehouse, data lakes, etc., or data meshes, all of these architectural patterns are natively supported within Snowflake. And all of that can be attributed to our storage layer. So this is the core of a platform, which is the optimal storage layer that we have sitting right in the center of the platform that supports storage of any data type. So you can store structured, semi-structured, or unstructured data and work on top of these data sets using the elastic multi-cluster compute. Now that forms the second layer in our overarching architecture. Now we've called this compute engine the elastic multi-cluster compute primarily because of the fact that it can basically scale across 3 different dimensions, as you can see at the bottom of that of the pie chart there. We'll jump into some of those dimensions, how we scale and how we enable performance through those scaling mechanisms. But keep in mind, the elastic multi-cluster engine supports not just SQL, but also other computing languages such as Python, Java, and Scala. Now, Snowflake is obviously based out of the cloud, and as a result, what we do provide, and we've provided this since day one, pretty much at Snowflake, which is compute storage isolation. Now, compute doesn't. What that really means, firstly, to take a step back, is that you can now scale compute regardless of the size of your storage engine and vice versa. And also, you've got compute isolation, and that powers a variety of workloads that can run on top of Snowflake. The third architectural layer is our cloud services layer. Now, this is really important because this is where the simplicity of Snowflake stems from. This layer hides away a lot of the complexity within the engine and abstracts it away from users. So you can now focus just on the value that you can derive from your data platform, which is Snowflake. So to give you an example, some of the capabilities that are covered by the cloud services layer are management of users, authorization, authentication, etc. It takes care of sharing. We'll jump into that in a second as well. But most importantly, it records all of your metadata for your underlying storage and your compute engine that provides a lot of the performance features. And also provides optimal security and governance, which we'll touch on in a little bit as well. Speaking about sharing and collaboration, that creates the fourth architectural layer, which is the Snowgrid infrastructure. Now, within Snowgrid, this is where you extract the value of Snowflake through not just your data, but also the connected ecosystem that you get provided around Snowflake. So this ecosystem, this layer, provides the cross-region as well as cross-cloud sharing and collaboration capabilities, along with our marketplace capabilities as well. That is one of the ones that I'm hoping to touch on in our hands-on lab today. So we look at how we can leverage the Snowgrid to enrich your organizational assets with other third-party assets that might be available for you in the marketplace. Okay. Now, with all that being said, Snowflake is called a data cloud, essentially because of the two core components that Snowflake comes with. Firstly, is the Snowflake platform in itself, which we've spoken about in a bit of detail. Secondly, it's all of the assets that come along with the platform. So these could be data assets, services, applications, ML models, AI services, etc., that get packaged together with the platform if you wanted to utilize it within our Snowgrid infrastructure. So that is what really makes Snowflake unique in the sense that you're not now really constrained to just your organizational assets. You get thrown into this wider ecosystem of all of these assets that you can tap into if you wanted to further enrich and derive value out of your data. All right. Moving along, this is an illustration of Data Cloud as it existed a few years back. As you can see in the note down at the bottom, that illustration was picked up 3 years back. And that, I guess, represents the power of sharing and collaboration that's happening continuously within Snowflake. So you can see a bunch of data points along with edges and nodes that seem to be quite busy at the center of the sphere there. That represents sharing and collaboration. So each of those nodes that fan out into other nodes could be interpreted as data providers, application providers that are sharing data and applications across a bunch of other consumers of those applications and data. A good example is COVID-19 data or weather data, even that's available in the marketplace that a bunch of other companies might be tapping into. What you see on the periphery of the sphere could be companies, organizations that are sharing data just amongst business units within organizations or within or across suppliers or across partners that are geographically close to one another. Now, that is a good representation of the data cloud. Now, obviously, if you looked at what that looks like now, that's going to be much more complicated than what you see on the screen there. So to simplify and tone things down, I've got an illustration from a couple of years back. All right. That should have given you a brief overview of the engine and the space that we operate in as well, and also along with that, a few unique capabilities of Snowflake. Speaking about marketplace and the Snowgrid infrastructure, you get a bunch of data assets like I was talking about. A couple of the good examples from a commerce perspective, Equifax, S&P Global data. From a weather perspective, I've got Carto, Weather Source, Precisely. I've got all of these other different marketing providers as well, and collaboration partners that we have around our Snowflake ecosystem. Feel free to check them out. All of these are listed publicly in our web pages as well. Now, these are just data providers. We've got a whole host of other providers that operate from an application space as well. You can now package complete applications within Snowflake using Snowpark container services, using the container infrastructure, and make them available on the marketplace that other consumers can tap into. So feel free to check all of them out. We've got a lot of customers that are using them in anger now. Cool. We've briefly touched on the Snowflake architecture, but What really makes Snowflake powerful is the cloud services layer that we spoke about. And the cloud services layer provides the best-in-class cross-cloud governance that you see on the screen here. So governance has always been top of mind for Snowflake ever since day one. Ever since we started, governance is one of our core notions that's been baked in from the bottom up into the platform. So every single feature that you use within Snowflake is going to be backed by the same level of governance, same level of security features that come across the platform. So you get a consistent governance experience across the platform. We think we at Snowflake, we kind of tend to think about governance across three pillars, three verticals. Firstly, at Snowflake, it's all about giving users and consumers the ability to understand their data. So giving them the transparency that they need to help them understand their own organizational data assets. And so to that effect, we've got features around classification, object tagging, etc., that help you understand your data. Uh, and also keep in mind, Snowflake collects logs and metrics data for everything that happens within Snowflake, really. So access history. So whoever is accessing data within the organizations, who's running queries, what sort of data is accessed, tables are accessed, views, etc. All of this is collected and recorded as logs and are made available back to consumers. And that is meant to provide the visibility that administrators of Snowflake platform might be after. Now, using this information and knowledge of your data, the next step or the next pillar that we focus on is to then protect your data using all of the control mechanisms that we have in place at Snowflake. We've got a few different ones here. Row access policies, row level security is a common and a popular one. I've got dynamic data masking. A couple of the other ones as well. We won't jump into these in detail. Feel free to check them out in your own time. But we've got all these different policies and control mechanisms that you can put in place to then control who accesses your data and how they access them as well. Now, thirdly, we've got the connected ecosystem. And like I said at the start, governance applies consistently to the entire platform. And that also covers the connected ecosystem that we've got around Snowflake. So regardless of whether you're sharing data around within your organization or across multiple other organizations around suppliers, partners, etc., you've got the same governance controls. So features such as secure sharing, for instance, make sure that you're sharing data as a provider while also adhering to your governance restrictions and controls. And also the consumer would be bound to the same governance controls. Features such as data clean rooms, for instance, can be used for marketing activation that help you basically co-locate similar customer bases without revealing individual entities amongst the customer base as well. So keep in mind, governance helps you protect the entire ecosystem regardless of where the data exists. All right. I'm hoping everybody's following along. Quick reminder for people that may have joined us a little bit later into the session. Feel free to check out the resources tab. Feel free to sign up to a Snowflake account if you've done that, if you haven't done that already. We will spend the next sort of 10 minutes going through a brief overview of Snowflake and some of the capabilities that we cover. And then we jump into our hands-on lab. All right. Now, in terms of the end-to-end capabilities, obviously, a decade back when we started in 2012, Snowflake primarily started as a data warehouse. And over time, we've massively expanded in scope. And what that means now for users within Snowflake is that we cover the end-to-end spectrum, right from ingestion of data from sources all the way through transformation, applying and running data engineering pipelines, running data science and AI workloads, all the way over to consumption and also gaining observability of your ecosystem. From an ingestion standpoint, we support features around both batch and streaming ingestion through our Snowpipe and Snowpipe streaming capabilities. From a transformation standpoint, obviously, like I said, we've got native SQL capabilities that are highly performant and are provided, and the performance is largely provided by a compute engine that can scale across dimensions like I introduced at the start, but also provided through our cloud services layer capabilities. Apart from SQL, sorry, we've also got Snowpark capabilities that provide you other coding languages such as Python, Java, and Scala, predominantly geared towards data engineering and data science workloads. All of the other expected capabilities within a data warehouse exist as well, such as stored procedures, user-defined functions, etc. All of them are natively available within Snowflake. We'll cover a couple of capabilities around zero copy cloning and time travel. That may be kind of new for people that haven't been used to Snowflake, so we'll cover them up in a little bit more of a detail. But yeah, stay tuned for that. In terms of orchestration, we've got native capabilities for them as well. So around orchestration, we've got streams and tasks that work on incremental data loads and help you apply transformations on incremental data loads too. I've got dynamic tables. We'll cover that in a little bit more detail as well. And from a consumption standpoint, Snowflake connects up with a lot of the BI vendors that are available out there in the market, but we've also got some capabilities natively in the form of Streamlit. So Streamlit as an engine helps you build out applications using native Python coding. And that is predominantly, again, geared towards data platform teams that have got Python experience and do not really want to rely on the BI side of things or the BI developers really to bridge the gap between or to reduce the gap between extracting data, loading them into the warehouse, extracting insights, and making them available to business users. If you still want to use BI development's BI tools, that's still natively available as well. You can connect up to Snowflake to other BI tools, but keep in mind, a lot of those capabilities are natively available within Snowflake in the form of Streamlit as well. Now, from an observability standpoint, we touched on this I guess briefly, all of the logs, like I said, is collected and stored within Snowflake. It's meant to give you visibility into the ecosystem. But again, from a notification standpoint, we've got alerts and email notifications that can be sent out natively from Snowflake. Again, from a resource monitoring standpoint, from a financial governance standpoint, we've got resource monitors and budgets that you can apply on the platform to keep a track of how much you're spending in terms of credits within Snowflake. And all of your logs and trace data can be stored in separate tables, analyzed, and we've also got native capabilities around event tables to help you do that. All right, not to forget, outside of the native Snowflake storage capabilities, we've also got support for Iceberg tables now. So Snowflake natively supports Iceberg tables, be it Snowflake managed or externally managed Iceberg tables, and we've got catalogs now as well to help you manage Iceberg tables if you want data to be stored outside of Snowflake for whatever reason, be it. Okay. I want to briefly touch on ML because we've massively expanded in that space, and a lot of the newer features tend to be related to ML, if not AI, and we've got a lot of investment going into this space. So when it comes to ML, we've got capabilities that kind of cater a broad set of audience. Firstly, we've got ML functions that you can use within your SQL code. And these ML functions are pre-trained Snowflake models that you can tap into if you don't want to build your own ML models. If you want a little bit more sophistication, if you want to build out your own models, if you want to train them, manage your features, etc., all of that is available using our Snowpark ML packages. So you can build out ML models through our ML modeling capabilities. You can create features, create feature engineering pipelines, store them, and centrally manage them within Feature Store. So we've got the ML ops capabilities as well. So you've got Feature Store to manage your features, you've got the model registry to manage your models, etc., and we manage the entire life cycle of model creation and also productionization. And all of your Snowflake ML capabilities can be run in an IDE of your choice. We've got Snowflake notebooks available as well to provide you a cell-based interface, predominantly what data scientists are used to using. All of this can be executed on Snowflake warehouses on the warehouse runtime. But again, we've got the container runtime as well for high memory, high parallelization use cases where you want to tap into GPUs. So that's available for you to tap into right now. All right. Moving along, a little bit on AI. I don't think we've got any session that we can go through currently without touching on AI. So to that effect, Snowflake has a lot of AI capabilities as well that we've developed over the last couple of years. Snowflake Copilot is a good example, which lets you translate English language text into SQL queries. So for people that are not used to writing SQL queries, want to bootstrap some of their pre-existing knowledge, you can use the Copilot to spit out SQL queries for you based on your English language questions. Moving along, we've got structured, also unstructured data analytics. Doc.ai is a good feature that lets you extract analytics from PDF documents. And we've also got features around Cortex, specifically Cortex Search, that lets you work with unstructured data and extract insights from unstructured data. Call center analytics is a good example where users try to get analytics and insights from conversations that call center users and customer service representatives would have had with customers. On the other side of things, like I said, we've got Cortex Analyst that helps you work with structured data and extract insights from structured data. So you can ask questions in English language, and Snowflake behind the scenes can execute a SQL query based on the understanding of your question and retrieve answers from underlying tables. That is Cortex Analyst. I think that should have given you a flavor of what exists from an AI standpoint in Snowflake. That's not the end all and be all. There's a huge variety of other capabilities that are available as well. So feel free to check them out in your own time. All right. Moving along, hands-on lab. This is when we jump on to the more interesting bits here. Prerequisites, like I said, you must have got access to Tasty Bytes, so you should have a quick starts link within the resources tab that you can jump into, and that should take you to snowflake.quickstarts.com or quickstarts.snowflake.com, and please open up Introduction to Tasty Bytes. That's got all of the modules that we'll try to touch today. There's roughly, I think, 6 modules there. We'll try to cover 2 or 3 today based on how we go with time. But if we have more time, like I said, happy to cover the other modules as well. Okay. Now, a little bit of a context on the customer, on the fictitious customer, like I said at the start, that we'll use to go through this Snowflake journey. We're going to be using Tasty Bytes as the customer. And we can think of Tasty Bytes to be a global food truck network that operates in a bunch of countries, 15 countries, 30 different cities, and they're trying to get onboarded into Snowflake. That's our assumption for today. And they've got a few different large goals. They're trying to increase revenue by 20% year over year. They're trying to increase sales. We've got a couple of other metrics as well, NPS being one of them. And so to be able to track and analyze of these data sets, they want to then move data into Snowflake. And that's the goal here. And we're going to be jumping into the shoe of a database administrator, in this case, Alex, who's going to be using Snowflake and using Snowflake to work with data sets, setting up of the infrastructure, firstly, working off assets, and extracting insights for business users of Tasty Bytes. We look at a couple of modules. Financial governance is an interesting one. We will definitely look at that. It's imperative to set up financial governance and financial guardrails across the Snowflake ecosystem. Luckily for Alex, we've got the infrastructure set up, so she doesn't have to worry about setting up infrastructure within Snowflake. That's one of the good things about using Snowflake, which is a completely managed SaaS service where you don't have to manage a lot of the underlying capabilities. So the infrastructure is first set up for you, and now we jump into setting up other financial guardrails before we jump into using Snowflake for your transformation capabilities and for creating insights out of your data. So before we do that, what I'm going to do is I'm going to open up Tasty Bytes. So if you jump into quickstarts.snowflake.com and if you start searching for Tasty Bytes, that should present you with the first recommendation here, which is an introduction to Tasty Bytes. Please open that up. And once you open that up, you should have the first screen that should give you a brief overview of Tasty Bytes that we've just run through. But on the second page, you're going to be presented with a GitHub link about midway in this section, highlighted in green for you here. So if you open that up, that should take you to a GitHub account that has got a bunch of scripts that we'll need to run to set up of the databases that we need for this hands-on lab, schemas, tables, etc. I'll dive into that and give you a little bit more context as we start jumping into those. But all the scripts are in here for you. And I've got a Snowflake account that I've created as well. That's in here for me. Sorry, I'm going to be using this account. Ignore the other account that I had. I've been testing this out just before I jumped on this hands-on lab. So once you sign up and once you log into Snowflake, this is the first screen that you'd see here. I've signed up to a Snowflake account as well, like I said at the start. I'm going to skip all of this for now. I don't want to load data. All of the data will be created through the setup scripts. But traditionally, once you load up Snowflake, the first step would be to load up data from your sources. But in this case for us, to speed through the demo, we've got data sets that we can copy from and create using our setup scripts. All right, click on skip for now. And I'll quickly walk you through some of the capabilities that are available once you pull up Snowflake. This is called the Snow Site window. That's the UI. And a couple of the capabilities that are available here, we won't jump into all of them. You can see that you've got 400 credits when you start up at Snowflake. You've got a free trial that ends in 30 days. So after this lab today, I think we'll only end up using a few dollars. So you would still have all these credits for you to utilize in your own time. So make sure you utilize them, maximize all the free credits that are made available to you. Okay, now we've got a bunch of tabs here. For our purpose, we're going to be looking at using SQL worksheets mostly to run our setup scripts and also for us to run the rest of our hands-on lab as well. There's a bunch of other tutorials here. Feel free to check them out as well. They've got some interesting sample queries, tests, etc. that should give you a brief idea as to the Snowflake engine. We've got notebooks capabilities, like I said, that gives you a cell-by-cell experience. We've got Streamlit, that is the Python-based development tool for creating applications natively within Snowflake. You can create native dashboards as well on top of your data that exists within databases in Snowflake. Now, quickly pulling up the next most important tab that we'll be spending some time on today. That's the data tab. Now, this is where all of your databases are going to appear. Right now, when you first created your account, you're going to see a couple of databases here. Firstly, that's you've got the Snowflake share. That should give you access to all of the logs and the traces data that I was talking about, account usage, query utilization, history of queries, etc. All of that should be available in this database. We've got sample data that you can use to run some sample queries as well. You've got some worksheets, notebooks that run some sample queries. Feel free to check them out. But to begin with, what you're going to see is you have a database and you've got a bunch of other objects within the first layer in the database. Now, we tend to call them schemas. And so when we talk about schemas, think of them as logical groupings of objects. So you can organize, you can create schemas, logically group your objects based on your SDLC cycles, based on your business units, etc., based on how you want to manage access to your data. And you get to manage them and organize them into schemas. And within schemas, that's where you're going to have all of your database level objects. You're going to have tables, views, functions, whatever you create. That's a brief overview of what we're going to be looking at today. But outside of that, we've got other AI ML capabilities as well. This is an interesting one. You can use the playground here to try out some of the capabilities that I was talking about earlier, creating Codex Analyst for your structured data analytics. So you can feed in a table there and then start asking some questions and it's going to return answers for you. I've got other capabilities as well. Feel free to check them out. There's a brief description on what each of them do. All of your models that you create for data science features are all available here. Got monitoring capabilities as well. Firstly, when you create a Snowflake account, you're going to be provided an account admin permission. So that's the role that you're going to see here, along with some account information. Familiarize yourself with all these roles here. We're going to be doing a lot of this with the account admin, at least for the setup, and then we'll start creating some fine-grained roles to give you an understanding of how we can then use roles to control access to underlying database objects. So using specific roles, depending on whether you've got access to these objects, you're going to get access to copy histories, query history, you've got dynamic tables that you can access, but also you've got a lot of capabilities around governance. We'll jump into that once we start diving into the hands-on lab as well. But yeah, feel free to check them out as we start exploring this Snow site window here. Cool. Now what we're going to do is, like I said at the start, we've got a GitHub page that should give you all the setup scripts. I'm going to quickly pull it up. And what I'm going to do is I'm going to copy the raw file from here. Also, as a quick reminder for people that may have missed this, All this is available with an introduction to Tasty Bytes. Within the second page, you should see a GitHub link that's highlighted in green there. Pop into the GitHub link, copy the SQL scripts here, and then we're going to go back into Snowflake and run these scripts to create all of our database objects that we'll be using through our hands-on lab today. Okay, so for that, what I'm going to do is I'm going to pull up worksheets and I'm going to, sorry, moving away my Zoom tab there. I'm going to create a SQL worksheet. So within worksheets, you can create there's a couple of different options that you can create a Python worksheet or a SQL worksheet. There's folders for you to organize worksheets under as well. And you can see which roles have been used in creating these worksheets too. I'm going to create a SQL worksheet for us. And so make sure that you follow these steps as we go through this process as well. And if you have any questions, feel free to put them in the Q&A window. We can help get them answered. All right, I'm gonna skip these steps here. You're gonna see, depending on the cloud provider and the region that you've selected, you're gonna notice an Ask Copilot option there. I'm not sure if all of you will be present to that option. I know some cloud regions may not still have Copilot enabled. So that's where you can start asking natural language questions and get SQL queries back. We're not going to be using that for now. What I'm instead going to do is I'm going to paste the script that I'd copied from the GitHub link, and we're going to run through the script. So in saying that, there's a couple of different ways in which you can run these scripts. You can run an individual command here. You can highlight the command and run it here, but make sure you don't do that. We're going to run through the entire script, and that's going to execute that in order. So to run the entire script, what I'm going to do is you can either highlight the entire script here using Control A or Command A, and you can click Run, or you can click on the drop down here next to the Run icon and click on Run All. So that should start running through our scripts here. It should take a couple of minutes before it finishes running, but as it's doing that, what I'm going to do is I'm going to quickly walk through these setup scripts with you and roughly give you an idea as to what these scripts are doing for us. Okay, so firstly, we use a particular role. So sysadmin is an elevated permission that lets you create and work off objects within Snowflake. All of these objects, all of these roles still roll into the account admin permission. Feel free to check this out in your own time as well. But using the sysadmin permission, we then start creating database objects. So I've created a database here, and I've created a few different schemas, and I've logically organize that based on the type of data that exists in the schemas. The analytics schema is the schema that I'm intending to expose to business users. So that'll be the final version of data products that you create after all of your transformations are complete. We've created a couple of warehouses here. And again, you're going to notice that they've got different configurations. We'll run through them in a minute as well. And we've got roles that are created. So this will let you control fine-grained access to your data assets. Using account admin or using sysadmin owns the entire database that it's creating in the process right now, but you can use the specific roles that we're creating on the fly to control which role has got access to which database objects, and consequently, which users got access to these database objects as well. All right, so we've granted access to specific roles, and then we grant access to databases and schemas to these roles, and also on warehouses. So anything within Snowflake will need to have access in order for a user to be able to access the underlying objects or schemas or warehouses. So that's what we're doing here. We're giving access to specific databases, to specific roles, schemas, tables, etc. And this is where we're starting to copy data for our use today, for our hands-on lab. So all this data is existent in an S3 bucket that we're copying across. And it's as easy as that. So you're going to create tables, you're going to create DDLs for tables. And this is pointing, the stage that we create here is pointing to an S3 bucket for which we've got the URL here. And then we start creating the DDLs for the tables, and we issue, as we scroll through the script, copy into commands to load data into these tables. And we've also created some views here, as you can see, that will create the final aggregated data sets that will be exposed to business users. But we've got everything that's in here for those tables and objects created for us, for us to use through the hands-on lab. Okay, now in a couple of minutes' time, that should finish running. We've timed it well. This has never happened. So all the setup scripts have finished running. As you can see, we've got a query duration as well. So the last query finished running in 32 milliseconds. But all of your query IDs are in here. So you can feel free to go through the query history in the monitoring tab, and you're going to see a bunch of queries now having been executed. And you can see runtimes of queries, how these queries have executed, the data that it's accessed, etc. Okay, now what we're going to do is, having run the setup scripts, now we're happy to run into transformations or whatever we want to run on this data. But before we do that, I want to quickly walk you through a couple of the other capabilities that we have. I think it's important to also understand the scale and the performance of the warehouses within Snowflake before you can start imposing and start creating the financial controls within the platform. So what I'm going to do is I'm going to jump back into our slide deck here and walk you through some underlying considerations that is good to have before we start creating those financial guardrails. All right, so if you remember, one of the things that I said at the start was the compute engine within Snowflake is powerful, and it's also unique because of the fact that we can scale across various dimensions. And what I mean by that now is, firstly, we'll look at the first dimension of scaling, which is scaling across. So, like I said at the start, we've got compute storage isolation, and you can now scale up, scale down compute independent of your storage engine. But you've also got compute isolation. And what that means is, in a typical business environment, in a typical data platform, you're going to have multiple workloads that are running, right? You can have ETL workloads, you can have BI workloads, data science workloads, all pointing into the same single ecosystem, which is the data platform. Now, the issue with having something like this is, you must have seen this in your previous experiences. You would have had ETL workloads or ELT workloads running overnight. So all of the resources are freed up for BI consumption over the day, right? And that creates a whole lot of latency, doesn't create or doesn't issue data for business users in real time in the right way and format as well. So now what we can do using the compute isolation within Snowflake is you can have different compute warehouses. And also keep in mind, when I say warehouses, that's the terminology for compute within Snowflake. So we can have different warehouses of different sizes, all these gears across the screen, different warehouses of different sizes for each workload. So you can have an ETL workload, and let's imagine the ETL workload is bringing a trickle feed of data, not large in size. So you want to start with a smaller size warehouse. The smaller size warehouse that we have available in Snowflake is an extra small warehouse. And that comes with one node, one vCPU, or one node with 8 threads, which is 8 vCPUs. And it scales up from extra small all the way up to 6XL. And every single time you move from a single size warehouse, a particular size warehouse, to the next size warehouse, you are essentially doubling up the amount of compute resources. So when you move from an extra small to a small warehouse, you get 2 nodes and you get 16 threads, sorry. And from a small to a medium, you get 4 nodes. So every single time you double up the amount of resources, that means double the amount of compute power. And we'll jump into how that ties up into performance and costs as well in a moment. But this is the idea. You can have different compute warehouses. You can have a medium-sized warehouse for your BI workloads, considering the complexity is pretty large for your BI workloads. And you can have a small warehouse for your data science workloads. That's compute isolation, and that's the first dimension of scaling, which is scaling across to support a variety of workloads. Now, the second dimension of scaling is interesting. This is scaling up. This is meant to support query complexity. So if you have high complexity in terms of your queries, more data coming in from your queries, or more data that's being processed by your queries, you may realize that your compute power is not sufficient. And traditionally, when it's not sufficient, it ends up getting queued. You don't provide good experiences for users, or the latency for data coming in increases. So in that case, let's consider you're running a data science workload, but you're running this in your dev environment, which may mean that you're not training your model with all of the data that's available. You may be only training it with a subset of data to prove that a capability exists or to prove out a particular hypothesis. Now, when you move it into production, you may be training off the entire data set. And what that means is you're working with large data, right? And in that case, a small warehouse for data science may not be sufficient. You may end up queuing. It may take a lot of time to compute and create and train your models. So now what you can do is within Snowflake, you can move from a small or an extra small to an extra large warehouse. Depending on your needs, you may want to move to a medium warehouse or a large warehouse, or even a 2x or a 4x warehouse. In this case, the example is we're using an extra large warehouse to free up and provide a lot more compute power so you can run your workloads effectively. That can be done instantaneously. So if you want to increase your compute warehouse, you do that either using the UI or you do that using code, and you instantaneously increase the size. And all of your other queries that are queued up on your small warehouse now get changed and they start running on your extra large warehouse. That's unique, and that's a big performance boost that you get out of using Snowflake. Before we jump into the third dimension of scaling, I'm going to quickly show you um, a quick graph that shows you the performance cost trade-off as well. What you see on the screen is an example in which we've used Snowflake to load up 1 billion records. So that's basically copy into statements loading up from a source database. And you can see here that using an extra small warehouse, it's taken us roughly about 13 minutes, and that's using one node. And as you start increasing the warehouse size, the time basically halves in terms of loading the records. So with a small warehouse, you get 2x the amount of capacity, compute capacity as an extra small warehouse. And now, because you get twice the amount of compute power, your queries end up running in roughly 6.5 minutes, half the amount of time. Now, as you move up in size to a medium warehouse, you get 4x the amount of compute power. And again, your query time halves again. So now when you try to overlay costs on top of this data, you're going to notice something that's really interesting. In Snowflake, customers are charged by the second. Now, when you move from an extra small to small, you're paying twice as much as an extra small warehouse. But since your workloads end up running in half the amount of time, your net costs are still the same. So you pretty much end up paying the same amount of costs as you move from an extra small warehouse all the way over to a large warehouse, and you kind of run your queries 8x faster, but you're still paying the same. That's what's interesting. Now, after this, you're going to notice some performance cost trade-offs here. That's because 1 billion records, you get a sweet spot of using a large warehouse and optimally tuning it for 1 billion records. But for other larger queries, other larger data loads, for instance, you basically get the same performance benefits in using much larger warehouses as well. Okay, now all that being said, third dimension of scaling is scaling out. Now, this is very interesting, particularly considering BI workloads. Now, when you have BI workloads running, you're going to expect multiple users using your dashboards, running queries simultaneously. And when that happens, what usually happens alongside with it is basically query performance degradation. There's a lot of queuing that happens on a compute engine where there's multiple queries coming up at 9 a.m. in the morning when everybody opens up their dashboards and starts writing queries on the underlying platform, right? And when the platform can't handle these requests, that's when queuing starts happening and it affects basically experience on the user side. Now, to tackle that, what you can do within Snowflake is for your marketing use cases, the example that we looked at earlier, you can use multi-cluster warehouses. So you can essentially create replicas of your compute engine, so essentially clones of your compute engine that can span out and create multiple compute engines, and that essentially parallelizes a lot of your queries. Think of it The analogy would be a load balance in this case. So all of your queries get load balanced into multiple different compute engines to give you the same sort of performance, same sort of user experience, the expected user experience, and get you around a lot of the lag that you might experience during peak times. And this can again be orchestrated just based on peak times as well. And that's where a lot of the efficiency gets driven. All right. Now time to jump on a hands-on lab. The first one that we'll look at is financial governance. I believe you must have all the information that you need and understand to get onto this hands-on lab. So let's get into this. Cool. So for that, if you open up the previous link that we were on, the introduction to Tasty Bytes, the GitHub link that we used to set up all of our resources is on the second page here. If you jump on the fourth page, that's where all of the vignettes are that we're going to be looking at today. The first one that we're going to look at is cost management. Just doing a time check. Open that up. And once you pull it up, you're going to notice a bunch of steps that are provided in here. I'm going to walk you through all these steps as we go through the scripts as well. But as you open it up, please open the second page and you're going to notice another GitHub link. And that's the financial governance GitHub link for you. So pull it up and we're going to do the same as before. We're going to open up and copy the raw file from here. So I'm going to copy the raw file. I'm going to go back into my Snowsite window in here. And I'm going to create another worksheet and paste it up there. So you must be on this screen setup as I'm showing you on the screen here. If not, open up the tab as you can see here that I'm pointing to, pull up worksheets and create another worksheet. So I'm going to click on create SQL worksheet by clicking on the plus icon here. And I'm going to paste the piece of code that we've just copied. And now for the sake of understanding, I'm going to rename this worksheet, call it cost management. And the previous one was set up. And you can do this, organize them within folders as well, as I explained at the start. And let's start going through the script now. So hopefully you should have all copied your scripts over. If you have any questions, quick reminder, put them in the Q&A window. It's very important that we follow through this and all of us are on the same page as we go through this hands-on lab. If you get stuck at any point, please flag a question. Cool. Now I'm going to be setting some context. Now we're going to be running through this line by line, command by command. We're not going to be running, sorry, I was on the wrong screen here, cost management. We're going to be running through this line by line here, just for the sake of our understanding as well, and see what it feels like to be using Snowflake and the Snowflake Compute Engine. So we're going to be using a role that we initially created, the TB admin role. That's got access to a few different database objects. So that's the database that we've created. If you open it up, you're going to see a few different schemas, tables underneath those schemas, views, etc. Feel free to check them out as well. Okay, now I'm going to select a particular command, a line here, and click on run. That's one way to run a script within Snowflake, or a single line within Snowflake. As soon as you run it, you should see some query statistics, query duration, a query ID. All that is important to understand so you can go back and analyze these queries. But we'll get into that in a little bit more detail as we get into some of the other queries here, and that'll make sense for us to start looking at the query IDs and understand what's possible in terms of using these query IDs. So the other thing that you can do to run these queries is you can click on a particular line as long as you've got a semicolon delimiter in there and click on run as well. That's going to use a particular variable. So we're setting some context in here. So we're going to create or use a role, use a particular compute engine, which is a warehouse, and use a specific database to run through this hands-on lab. And all the queries that we run is going to be running. They're going to be running within the same context that we run or create at the start of the script, or you can change the context as we go through the script as well. The other way that you can run a particular line is you can click on a line and click on Command Enter or Control Enter, and that's going to run for us as well. All right, I'm going to set some tags for this particular session. For a bit of a context, tags help you basically add metadata to whatever you want to use and understand within Snowflake. In this case, we're setting up tags on the session so you can go back and understand things such as what has been the cost attribution for all of the queries that you've run in the session, for instance. What are the queries that you've run with the session? So you can basically go back and filter down all of your logs and traces based on the tags that you've set up here. All right. What we're going to first do is we're going to be creating a warehouse for us to use. I'm going to select that and hit run. So a couple of configuration parameters in here to keep in mind. Warehouse type, that's standard for now. Ignore that. What I'll focus on today is a couple of the other ones, which is warehouse size and the min-max cluster count. All the other configuration options can be basically fetched from our documentations. Feel free to check them out. But what's important is to understand the size of the warehouse. So at the start, what I introduced you to was how you can move from a particular size warehouse to a higher size warehouse. In this case, we're going to be starting off with an extra small warehouse, which is a smaller size warehouse that's made available. Keep in mind that in itself is pretty powerful. It comes with 8 threads. And we're also setting up a min-max cluster count, which means that we're setting it up for multi-cluster usage as well. So when there's complexity in queries, or sorry, when there's parallelization that's required for queries, multiple queries that are coming in, multiple sessions that are firing queries, you can use the min-max cluster count here. So it basically spins up 2 clusters at the same time. That can go up to 10, and that's now being expanded as well. So you can increase your cluster count to 10 as of now. Okay, and what you're also going to notice is we've got an auto suspend time. So your queries or your warehouse is going to be suspended after it runs for the first, or after it is idle for more than 60 seconds. So that in itself is a cost control mechanism for you. So if you forget to leave your warehouses turned off, if you leave them on, they get turned off based on the parameter that you specify here. It is set to auto resume. So as you run on a query, it's going to auto resume it for you, and it happens pretty much instantaneously. You don't have to sit down, wait for your warehouses to start and initialize for you to then have it available. And predominantly in a lot of the data platforms, for a warehouse to be available, it takes a few minutes. And within Snowflake, it's a bit different. And it's been this way ever since the start. You get a warehouse, you start it, and it becomes available for you instantaneously. Okay. Now, using that warehouse, I'm going to change the role that we're going to be using. So we've created the warehouse. I'm no longer in need of using that elevator permission. We no longer need to create warehouses. So I'm going to be using a particular role that is essential or sufficiently enough for our needs for this particular hands-on lab. And I'm going to be using the warehouse that we just created. So I'm going to highlight these 2 commands in rows 107, 108, and I'm going to trigger them up at the same time. Okay, now that's finished running. Now let's see what it looks like to run a query with an underlying tables and stuff like, right? Follows ANSI SQL, the basic standard SQL that all of us are used to. So I'm running a very simple select statement on a table that exists within the raw pause schema. As you pull up the raw pause schema, you're going to see a bunch of tables in there. We're going to be looking at the truck table. The menu table here. So I'm going to select this and click on run, and you're going to see results come up. And essentially, we've got about 6 records come up here. You can see the query duration. That's fetched the results for us in less than a second. Got 6 records here. What you can do is you can click on the ellipses here next to query details and click on view query profile. And that will bring up another window for you that'll give you a summary of the steps that Snowflake has undertaken behind the scenes for you to fetch the results. And you can start seeing some important statistics around total execution, the number of bytes that it scanned. And this will all be a little bit more relevant and I think a little bit more useful when you're running this on large tables where you want to improve performance, when you're joining multiple tables, when you're running complex pipelines, etc. All of this becomes really helpful. Okay, now I'll close that one down for now. And let's run the next command here, which is I'm going to alter the warehouse and increase the warehouse size. So you don't necessarily have to have another warehouse up there, which is of a larger size. What you can do within Snowflake is you can instantaneously upsize your warehouse, like I said. So from an extra small, I now change it to be an extra large warehouse. You can see the extra small warehouse size here. You can see the role setting here as well. All of this can be changed here, but I'm going to be doing this via code. So I'm going to click on that particular command, and you can see that that statement is executed. And what we should expect is that warehouse has been instantaneously converted to extra large. That's basically it. It's turned off by default, but you're going to notice when we run a query here, it's going to turn on for us automatically, and it's going to do that instantaneously for us. So it's already started executing for us. This is a much larger query. It's looking at a much larger set of records for us. So it's scanned through a bunch of records, created or come back to us. It's come back to us with 222,000 records, and it's done that in 6 seconds. That's pretty quick considering the size of data that we're dealing with here. So I'm going to open up query profile, and you're going to notice a much different, a much more complicated query profile here. So that's done a bunch of things for us. And some of the interesting statistics here are table scans, so the amount of time that it's spent on table scans, the amount of time that it's spent on processing versus local disk input and outputs. So feel free to check all this out in your own time. There's a lot of useful information here. But what you can now see is that it's scanned roughly about 2 gigabytes. And that's the amount of data, that's the volume of data that we've been dealing with in this case. Cool. Let's close that one down. And now that I've run this large query, let's say I don't need access to such a large warehouse. Now, what I can then do is I can scale back the size of the warehouse to an extra small, and that scales back down instantaneously. And since you're paying by the second here, you only pay for those few seconds that you've executed this query with using an extra large warehouse, and then automatically you start paying for the extra small warehouse that you've scaled it down to. All right. With the extra small warehouse, you can suspend it now, but it's already in a suspended state now. So I'm going to let that aside. If you run that, you're going to notice potentially an error. You can do that. That's fine. But it's suspended for us by default. Okay. Now, with the understanding that we've got so far, let's look at what's available for us to set up as financial guardrails for us to begin with. There's a whole host of things that you can do, but I'll walk you through some of the brief initial necessary steps as well that you can work with and play with in terms of parameters to set you up for success within Snowflake when you start on Snowflake. So for that, I'm going to look at some of the parameters that are available at a warehouse level. So I'm going to run this command, and that should fetch us a couple of parameters that I can tweak and play with in terms of my warehouse settings. So what you can see here now is my timeout is set to be 172,800 seconds. That's roughly 2 days. Now that's what that's saying is for queries that are running for 2 days continuously. It's only after that time period that is going to get automatically turned off. Let's say I don't want such a large timeout value. I'm only executing basic queries. And if by mistake there is something wrong with the query that makes it run for such long, I don't want to incur the costs for it. So with that being in mind, as the database administrator, putting myself in the shoes of Alex, what I can now do is I can change that parameter to reflect what I want. In this case, I'm changing that to 30 minutes. So what that's going to do is if a query is running for longer than 30 minutes, it's going to automatically turn off the warehouse for us. What I can also do is change the queue timeout, and that is how long a particular statement has been queued for. And if it's being queued for longer than that, it's gonna basically time out those queries as well. So I'm gonna change that to 10 minutes, yeah, 600 seconds. I'm gonna quickly run that. And yeah, that's finished running. Now, all of this that we've looked at can be done at an account level as well. So you may have multiple users using your Snowflake account within your organization. You can have multiple databases, schemas, etc. Or you can have multiple warehouses. So in the case where you have multiple warehouses, you may want to do this as an account level to achieve standardization across your entire platform. So for that, in this case, I'm going to need an account admin permission to work across the entire account and change these parameters across the entire account. And I'm going to set the same values for us at an account level. In this case, just for the statement timeout, I'm going to change that to 5 hours with the assumption that there could be other long running queries that I might not be aware of as an account admin in other business units, let's say, that could be running for much longer. So in this case, I'm setting that to 5 hours. I'm going to trigger that up. And for queue timeout, I'm setting that to be 1 hour. So that should hopefully give you a feel of some of the controls, some of the knobs that you have to change and achieve a sense of control within Snowflake. Now, the other thing that you can also do is set up resource monitoring. And what that lets you do within Snowflake is that you can set up a credit quota, as you can see on line 225. In this case, I'm saying 100 credits. And that's monitored at a monthly basis here based on my frequency. And you can basically decide what you want Snowflake to do when it reaches specific thresholds that you've tagged against the credit quota. So in this case, what I've said is when it reaches 75%, it notifies the account admins. You can change that to your needs. When it reaches 100%, it's going to suspend my warehouse, but it's still going to let my existing queries run, my queued queries run. At 110%, regardless of whether there's existing queries, it's going to turn off my entire warehouse, and that's suspend immediate. And that's, again, a little bit more of a control that I achieve using resource monitors on my Snowflake ecosystem. And for this, you're going to need the account admin permissions as well. Okay, that's resource monitoring set up for us. Let's kick that out for us. And once you've done that, you've got to associate the resource pointer at the warehouse that you want to attach this resource monitor to. And you can, again, decide which warehouses that you want to achieve these controls over. You may have a production warehouse that you may want to let running regardless of the credit limits that it's reached. You may have other warehouses that you may want to closely monitor and control as well. So in that case, you can apply these controls on a specific warehouse, or you can apply them across warehouses in your account as well. The other thing that I said to you at the start when we started the script was tagging. Tagging can be also used as a mechanism for cost control. So you can create tags. In this case, I'm creating a tag calling it cost center. Let's run that. And I'm going to attach this tag to my warehouse. And I'm going to create a value for the tag. So keep in mind, tags work around the concepts of key value pairs. So you can set up values for tags. In this case, the cost center is set to be development team. Or you can associate your cost center to other business units in this case as well, that you want to understand as to how they're using your warehouses, how many credits they're consuming from your warehouses, etc. So in this case, I'm going to set it to development team because I know that this warehouse is being used by the development team. And at the same time, I can use this tag and attach this tag to all of the warehouses, all of the objects that the development team is using. And so at the end of the month, I can go back and say, these are the amount of credits that the development team has used this month. That's just one of the examples of how tags can be used. What you can also do is you can go back in a Snow site and visualize all of these that you've just created. So I'm going to duplicate this tab for us. I don't want to move away, and that'll basically mean that I've got to come back and re-navigate to this. So I'm going to open up my admin tab, and we're going to look at cost management. So again, as an account admin with the elevated level of permissions, you're going to look at all of the activities within your account, and you can start seeing what cost attributions are. You get some insights from Snowflake as well to help you manage your costs effectively. We've only run a few queries now, so there's not a lot of information here, but you can see what the consumption has been. So we started off at 400 credits. We haven't used so much so far. We've roughly used 0.2 credits, and that's mostly been at the TBDE warehouse that we've used so far. And you can also drill down by the tags that you've created by the cost center, and that's going to just show you costs that are attached to that tag, right? And then you can start seeing other costs as well, storage costs, data transfer costs. So all of this information is there in here for you. Resource monitors that you've created, they're all available for you. Or you can also create resource monitors here using the UI here. There's budgets as well that let you monitor specific objects within Snowflake, specific databases, specific services within Snowflake, and achieve a level of control over them as well. Okay, now in the interest of time, I'm going to go back to my other window and let's run all the reset scripts here. So everything from line 290 onwards, let's select them all and click on run. So that's just going to run the selected scripts for us. And that's just resetting of the steps that we may not want to continue and persist for our next lab. All right. Once that finishes running, I'm going to speed up a bit in the interest of time. I'm going to go back into my deck and walk you through, walk you through the rest of our content for today. So we've gone through financial governance. That should give given you a feel of what's achievable within Snowflake in terms of gaining control. There's a bunch of other things as well. Check them out in your own time. Transformation. Now, to understand transformation, I think it's important to understand how the storage layer works within Snowflake. Now, the storage layer, like I said at the start, it's unique in the sense that it works off the concept of micropartitions, which is a columnar compressed and optimal way of storing data. And these micropartitions are immutable, right? And what I mean by that is you can't really update these micropartitions. As you update your data, you're going to have new micropartitions created for you. And all of the metadata characteristics, information about these micropartitions are served and stored into the cloud services layer. And that's what's going to be used to achieve query performance and efficiency when you run your queries. So when I say that, the kind of data that we collect for each micropartition are listed here. So number of rows that are existent in each micropartition, the min and max values of columns in each micropartition, number of distinct values, all of this is collected and stored within our cloud services layer. And that is essentially used at query time for us to understand, based on your query, where the specific data that's being looked at by the query exists, in which micropartition it exists, and specifically for large databases, large tables, you can imagine that's going to be hundreds and thousands and millions of these micropartitions that are created underneath. And so to effectively fetch data from the right set of micropartitions, these metadata statistics are used, and that achieves the desired level of efficiency for us. Now, in saying that these micropartitions are immutable, we get other benefits as well. And that's where features such as zero copy cloning come to the party. There's another feature as well, time travel. We'll jump into that in a second. But essentially, when you think about zero copy cloning, think of it to be a way to achieve your SDLC cycles. All of us may have used different set of environments. We may have used dev environments, UAD environments, or we may have just used prod environments in smaller scale settings. If you want to typically have multiple environments, what it really means is you duplicate the amount of data that exists within each of your environment. And so you can run processes, make sure their work is expected in your dev environments before you progress them up into your prod environments. Now, to avoid that complexity, what Snowflake provides is the concept of zero copy cloning, where you can create a clone of your environment. In this case, I've got a prod environment, but in order to test some processes, I can create a zero copy clone, call it dev, and what it does is it only creates metadata pointers to my micropartitions. It does not double up data, does not create additional micropartitions. They merely just metadata pointers. So that reduces massively the amount of storage that you need to take care of when you're managing these different environments. And they are live as well. So when you make any change on your dev environment, let's say, it creates another micropartition, but that's completely independent from your other environment that you have, which is the prod environment. So any change that you make from there on, they get isolated for a particular environment or a zero copy clone. Okay. And then you may have another environment that's created. The same logic applies. All right. The other cool feature that micropartitions create for us is time travel. And this is really interesting, right? So you can have, let's say, the following micropartitions at a particular timestamp at T0, and all of this is recorded within Snowflake. And when you make a change, let's say you make a change to update your existing table, or you update a column, and because micropartitions are immutable, you create another micropartition. and you've got one additional micropartition, let's imagine, at timestamp T1, right? Now, what time travel means is, firstly, before that, we've got other ELT jobs as well that's bringing in more data. What time travel means is, let's say um, you've you've made an incorrect update on your data, right, on your table. Traditionally, what you would then be forced to do is you would be forced to then recreate your tables, run your DDLs again, bring in data loads again, and go back and run all these processes again just to make sure that you've got a consistent view of data again. So then you can reapply your updates on your table. But with time travel, you can instruct Snowflake to go back to a version of data as it existed at a particular timestamp. So it's done using simple Snowflake commands, SQL commands I'll show you in the demo. And it uses at and before values within Snowflake to go back in time. The other cool thing that it also can do is it can undrop tables again, and it helps against accidental deletions. Wish I had this feature when I ended up deleting a bunch of tables as well, and everybody knows how much of a headache they can cause. Okay, now moving along from this, let's jump on to the hands-on lab for transformation. Let's quickly get across this. What I'm going to do is go back into my tasty bites. We don't need cost management. We've seen that. Let's pull up transformation. So again, in this, following the same drill, open up the second script here, second page, and pull up the GitHub link that we have midway here. Click on the green highlight. That's going to open up the GitHub link, and let's copy the file from here. Hey, I'm hoping that everyone's still following along. If you have any questions, like I said, ask them out in the chat window. What I'm going to do is I'm going to go back into Snowflake, create another worksheet like we just did before, and I'm going to paste all of the data in here. Okay, and I'm going to rename this transformation. Cool. Now, we've discussed about zero copy cloning, time travel, etc. Let's see all of that live in action. Okay, now I'm going to be using specific role context in here. Let's run them all together. I'm going to be using a specific role, a specific database. Let's trigger them on. And I'm going to be using a specific query tag as well for the session. Sorry, there's a bit of a bug there, I'm pretty sure. Let's rerun that. Yep, that's executed successfully. Now I'm going to run a specific query tag as well that can help me monitor all the queries that I run in the session. Now to demonstrate zero copy cloning, all that you're doing is, in order to create some additional processing or additional columns in your prod environment, you may not want to work off your prod tables as well, just to make sure that you're not doing something wrong. Or at the same time, it can be at the same time being queried at real time by your consumption layers. So you may not want to really work off your prod tables. So in this case, I'm going to create a dev table, and I'm going to clone my prod table. That creates a zero copy clone for me. So I'm going to highlight that and click on. That should create a new table for me. And all that's creating is metadata pointers. It's not duplicating the data for me, right? And I'm going to be using a specific warehouse to run my queries. So now let's look at what we have in the dev table. So I'm going to click on run. And as you can see here, we've got trucks information here. So the year of manufacture, the make and the model of the trucks. And again, the values here may not be consistent. So you can see there's an underscore after Ford here. We may want to clean this data. We've just ingested this data from the source. So typically you'd engage in data cleaning, data transformation, etc., to make it available in a shape that is expected at the consumption layer. So we're going to demonstrate one of those capabilities within Snowflake. Now, what I'm going to quickly show you before that is, let's quickly run. Let's ignore line number 92. You can suspend the warehouse if you want to. You can restart it. But let's run command that starts line number 96. Sorry. Let's run that now. And what you're going to notice is that's finished running in 290 milliseconds. I'm going to just make sure we run that again to demonstrate a concept here. That's now finished running in 70 milliseconds. And the reason for that is the cache that Snowflake has created. So if I open up the query profile here, what you're going to notice is a query result reuse. So it's not scanning all of your data again. That saves a whole bunch of time. There's a bunch of caching mechanisms that are available in Snowflake that speed up a lot of operations. So this, especially from a BI use case perspective, if you're running the same identical query within the 24 hours of the first instance of running the query, it doesn't really use credits for you. It's still not using your warehouse credits. It's not rerunning the query for you. It's merely just fetching your answers, your results from the cache that Snowflake manages. And I see customers that are using this really effectively for their production consumption use cases, especially for BI tools. That's really powerful. Okay, now in terms of making my updates, I want to clean this data a bit. So I'm going to set Ford wherever it says Ford followed by a suffix, which is an underscore. So I'm going to update the table. So let's run line 126. So I'm going to click on run. And hopefully that should have made the changes for me. And you can see that the number of rows updated are 161. Let's see what data looks like now. And I want to make a few additional transformations too. So I'm going to quickly validate the transformations that I'm doing here, which is basically I'm creating a truck type column, which combines my make and model along with my year as well. So that's the transformation that we've created here. We're concatenating all of the columns. And I'm happy with that. So let's go and add this onto the table. And I'm going to alter my table, add a column. So that's the DDL there. And I'm creating a new column, creating that as a varchar. And now we get to replace or update the table using the transformation that we've just defined. So I'm going to run line 146. That should create the new column for us. All right, that's updated 450 records for us. Let's quickly see what that looks like now and make sure it's all running as expected. So line 151, click on that, and let's hit run. Okay, now that's created a truck type for us. But the issue here is, as you can notice, we don't have spaces to differentiate the year, make, and model. Now, traditionally, if you want to rechange this, you would have to recreate the table, update the table again, run the process again. And if you have hundreds and hundreds of processing that runs behind the scenes, it becomes a painful exercise. But in Snowflake, what you can do is you can use time travel to go back in time and get a consistent version of the table and just run your process once again. So I'm going to run query that starts line 174. That will help me get the query ID. And that's the power of using query history or all of the logs that are held within Snowflake. So what I'm trying to do here is I'm trying to get the query ID of the query that we executed just now, the most recent query ID. And I'm going to be using that to go back to a version of the table that existed before we ran this particular query. And we're going to be using the query ID identifier to help us do that. And as you can see, that's the query ID there. And I'm going to set a variable to be that query ID. I'm going to run the next snippet. And that should have created the variable for us. And now what I can do is I can use the before statement to basically validate that the table exists. I'm just running a select now to make sure that we're moving to a consistent version of the table as expected. And as you can see, the truck type values are all nulls for us, which is because we hadn't created the truck type or we hadn't updated the truck type column at that point. So now being happy with that, I can go replace my table as it existed before that query ID. So I'm going to highlight the next snippet and click on run. So that's going to create my statement now, or create my table now again, as per my query ID and as per the time travel that we've dictated. And I'm going to update the column. Now again, having a space that's defined there. All right, so that should have created the table as expected. And what you can now do is the other power of Snowflake is you can swap the tables. Now that you've seen how you can now create a dev version of the table, you don't really, again, have to rerun this process for your prod layer. You can basically swap the underlying micropartitions and change your prod layer to point to the micropartitions that refer to the dev layer of this particular table. So I'm going to swap the table. And that should have created the table for us again. And let's have a quick look at the prod table, the truck. And as we can see here, yep, those changes have propagated into the prod layer as well, as expected. And now we can drop the table that's not necessary, which is the def table. So I'm going to run the next snippet, which is line number 255, and I've dropped the table. But here's where I've made a mistake, and I've done this deliberately to show you what it means to undrop the table. So now, because I've done this by mistake, let's imagine I, as a developer, can go back and say, let's undrop the table. And that uses time travel again underneath Snowflake to undrop the table and make it available for us again. And now I can drop the right table that we were after. That's it. All right, so that's a little bit about transformation. I'm going to reset all of my cells here. So just checking time. I don't think we'll have the time to go through the collaboration module that I was intending to go through, but feel free to check that out in your own time. I'm going to quickly give you a rundown of what you can do, but also keep in mind there's other features that we have around transformations that we didn't look at today. Dynamic tables is a really interesting one that helps with orchestration. So you can create a SQL query that gets encapsulated as a table, and dynamic tables help you refresh these tables for you using a lag window that you specify. So you can specify at what lag you want these dynamic tables to be refreshed, and it only refreshes the incremental data loads that come from your sources. So you're not working off a large data set every single time that holds your, or that lies underneath your tables. That's dynamic tables, and it helps with orchestration. We've also got streams and tasks, which achieve the same functionality as well. Streams help you get, as the name implies, a stream of records, and just the incremental records using metadata pointers to signify what additional records have you seen in the underlying tables ever since the last time that it was processed. And you can use tasks on top of streams to apply processing on data. So you can apply tasks and say, hey, run the SQL query for me every few minutes, and that's going to orchestrate a task and create a table or another object for you based on your incoming stream of data. The same thing is essentially achieved using dynamic tables, but dynamic tables is packaged together using both streams and task capabilities that is packaged together. But again, streams and tasks can give you a little bit more flexibility. Okay, collaboration, like I said at the start, gives you a bunch of potential within Snowflake. If you're used to using the traditional collaboration techniques, you must be used to using FTPs, APIs, or using even ETL providers. The issue with these is that you lose control over your data, right? Once you move data out of your platform, you essentially lose control. You may have different governance controls on your data within your ecosystem, but once the data moves outside, you basically lose control. And there could be different governance or inconsistent governance controls that are basically applied to data within your ecosystem and outside your ecosystem. And when you have to transfer data, it means delayed access to data, right? And again, doesn't really support cross-cloud and cross-region sharing. But within Snowflake, all of these limitations are basically resolved. You have cross-cloud, cross-region sharing, data is instantaneously available through shares. So check out the marketplace quick start that we have, and that will show you how all these limitations are basically removed. All right, Snowflake Marketplace there for you. Check it out. You get access to a whole bunch of data and apps. It eases the procurement process. You don't have to go through a third-party provider just to get access to new data assets, new apps, or if this is natively available within Snowflake. And the biggest value add is that you cut down on integration costs. You don't have to create ETL pipelines and manage these pipelines for you. All of this is natively available within Snowflake as a share for you without having to physically move data outside of Snowflake. Consumers consume data from the provider's account, and you're not really moving data. That's the power. All right. We looked at a lot today. I've covered quite a bit. Here's a quick summary of what we looked at. Looked at creating databases, tables, how you set up the initial infrastructure within Snowflake. We looked at some transformation techniques, how we clone tables, how we use time travel, etc. Around Marketplace, feel free to run the quick starts on your own. There's governance quick starts that you can run as well. So there's a bunch of things that we haven't covered today. Feel free to have a crack at it. You're still going to have the free credits from the platform that we've just signed up to. So yeah, feel free to maximize the platform. And yeah, thanks for your time today. Hopefully you've got value out of the session. Feel free to check out other resources, other sessions that we've got coming up. And if you want to deep dive into any individual specific capability into Snowflake, call it ML or AI, there's sessions that we've got coming up as well. So feel free to check them up, register, and sign up for these sessions. But until next time, thank you.